now that the competition is coming to an end, there have been a couple of questions on how to use the training data and how to load it appropriately in Matlab. So here's an example of how to traverse through all of the subdirectories in the training set and print how many files do we have in each subfolder. We are looking first into the simple example, and after that we will take a brief look into a more complicated example where we actually open the files, load the deep features related to number of files, how to sample that. So the first thing in the simple script is that I set the path where my training data is located. In your case it will be in a different place, but anyway you have downloaded and extracted the data into some folder, and there should be this train folder there as well. We are using Matlab's function called dir, which gives the directory contents, all of the files and folders that are in this path. And it is entered into this variable, although in these folders in the beginning there are all the files and folders, not only folders but also all the files that may appear in this directory. Nevertheless, when I go through all of the folders in my list, I always first check if this is really a directory or if it's a file. These folders is actually an array of structures where I can access certain properties. The interesting properties are in this case the indicator, binary indicator, whether the kth item actually is a directory, and the name, which is the name for the kth item. These are the two things that I'm accessing for each k. Now, if this doesn't take me back to the for loop, or if I really am looking into a real directory, if the kth item is a directory and the continue did not take me back to the for loop, then I construct the full path. Namely, I need to concatenate this path, this long string here, and then the kth folder name in here, and then the template for the files that I want to look into. So all my files that I'm interested in have the ending deepfeatures.csv. So I want to look into those only. So full path and dir applied to full path gives me the list of files that have this ending in this particular folder with index k. I'm recording how many of those files I have and then simply print, okay, this folder contains this many files. Let's see what happens when I run this. As we can see, the end result is such that in folder this one I found this many files with the deepfeatures.csv end. In this file directory I have only one, in here 5, in here 6, and so on and so forth. So basically with dir and a for loop you can go through all of the subfolders and see what's inside of those. To simplify things a bit further, I also have another version of the same script. The beginning is exactly the same. I set the path, I find all the folders, I go through all of the folders in for loop and print how many files I have. But in addition to this, in this script I also load features in such a manner that I find a pair of similar images and their corresponding features, and a pair of dissimilar images and the corresponding features. Of course, now that I'm looking into the kth subfolder, I first need to check if there are more than one file, because otherwise I cannot make a pair of similar images. That's not possible if I have only one image in this subfolder. In this case, I simply skip this folder and move over to the next one. You might think of something more intelligent if you wish, but this is a simple strategy to skip those maybe less than 5 folders that have too few files. Then what I need to do is to find a pair of images within this folder. This pair will represent 2 pictures from the same person. Now there are several strategies for this, but I'd simply choose 2 indices at random out of all the files that are in this subfolder. So for example, for one person I might have, let's say, 8 images. I choose randomly 2 out of those and use that as an example of two similar images. I'm using Matlab's ready-made rand sample function, which takes a random sample of two items among all the integers between 1 until number of files. So for example, if I have 8 files, 8 images in my subfolder, then I would choose two numbers from the range 1, 2, 3, 4, 5 and until 8. Then I have two numbers in this vector. I read the first file first, which corresponds to the first index in here. So I extract that. So index 1 is maybe now the number, one of the numbers between 1 and 8. Then I construct a full path in a similar manner as before, and then I use CSV read to read the CSV file into vector called feat1. I do exactly the same thing for the index number 2. In indices I have two numbers that are separate. They are different from each other and all correspond to a number between 1 and 8, or how many files there are in my subfolder. Index 2 will contain this index. Full path 2 will contain the corresponding file name, the CSV file, and feat2 will contain the features after passing through CSV read. So now what I have is 4096 numbers, the feature vector for person X, and another feature vector for a different image of person X. Anyway, these represent feature vectors from two images of the same person, whatever the folder at each time may be. What I want to do in addition to this is to find a feature vector for a different person. These are of person X. Let's find a feature vector for person Y in order to generate a sample how feature vectors look from different people. Read a random different person file. So we need to take a look into the folders once again and find a folder which is different from current folder. And what I'm doing in here is that I select that random. Randy gives me a random integer between 1 and this number. So I just select a random folder. Basically that's what it is. So index will point into a random folder among all of the maybe around 270 folders that there are in the training data. Now there might be the rare opportunity that the index is actually pointing to this current folder, meaning index might be exactly the same number as k. So accidentally in this very rare occasion it might happen that I'm taking two feature vectors that I assume that are from different persons but might be actually from the same person. If it would happen that Randy would give me exactly the same number that I'm now looking into. The probability is really small, but nevertheless I want to check that this is not the case. I want to iterate until we really have a different folder. This might in principle happen 2 or 3 or more times, although very improbable, but let's do it like perfectly. I have here an indicator which is indicates whether I have found a different folder. Let's initialize that into 0, assuming that we have not succeeded yet. While this holds, let's take the name of the folder that we randomly selected and check first that it is actually a directory. Check that it's not the current directory. There are no images in this master folder. Or also it seems that dir also returns the parent folder for the current directory. There are no images there either. There are no deep features in there either. So I want to skip all items that are not directories, then the current directory and the parent directory. If any of these holds, if I'm not looking into a proper item, then let success be equal to 0 again. It doesn't change from here. And let's try another index. We are generating another random index because this one was not successful. However, if these do not hold and I'm looking into a proper item which is a directory that contains deep features, then I set success equal to 1 and after that I will get out of this while loop. And then everything is exactly the same as before. Here we extracted picture number or feature set number 1 for person X, feature set number 2 for person X, and now we do exactly the same thing for this another person Y. First I construct the full path, then I find all of the files from this folder. There might be several files, and usually there are several files for the second person. And what I need to do is to select randomly one of those. I'm doing it in here. Then I construct the full path to this random file in this random folder. And finally read in the CSV file. And what I have done so far is that now I have two vectors of 4096 numbers that represent features extracted from the same person X, whoever is in the kth folder, and another feature vector that is definitely from a different person. So this gives me the possibility to generate samples of differences of features from same persons and different persons. What I do is that I save the differences into feature vector X and store also a code 1 or 0 representing whether these are from the same or different person. In here I can compute the difference between the same person features. In here I compute the difference between the different person features. This is from the first person, this is from the second person. Of course you could additionally compute feat 2 minus feat 3, which would be another example of feature vector difference for two different persons. And finally I add to my feature matrix X, I append to the bottom the difference 1, which is an example of differences of feature vectors from same person. I'm not actually quite sure if this is a column vector. So what I'm doing in here is that first I make it into a column vector. This is definitely a column vector, and then transpose. So it will be a row vector. So I'm adding to the end of X, to the bottom of X, I'm adding a row vector of size 4096 numbers. Also, I'm appending Y with the indicator whether this is the same or different person. And in my case, I'm adding 1 at the bottom of Y, stating these are representing the same person. And the same thing for the two different persons. This is the feature vector, and for that I store the code y equal to 0. Now when I run this in Matlab, let's see how long it takes. It doesn't seem to be awfully slow. It is loading the files one by one. Let's see how long it takes. Okay, now we have loaded all of the pairs from each file. Of course, you can generate far more examples of pairs, but in this case I wanted to keep it simple and just take one pair of similar and different for each folder. Now let's see what we have. As a result, my feature matrix looks like this. There are 506 examples of feature vectors of this dimensionality. And for each I have the information whether these are from the same person or different person. If I briefly take a look at what's in Y, we see that every second is an example of different, every second is an example of similar image. And then if I also take a look at X, for example, it's first row, which is supposed to be from the two same persons. I see that there are some numbers represented there, whether or not that makes sense, but that would be the input for the SVM. Now the next thing to look into might be the SVM train function, which is part of the Matlab's SVM functionalities. Actually, FitCSVM is the newer version, which is probably the interesting thing to try. So what you want to do is to train an SVM model using the information that you can find from this help. and also after that you can predict for each pair that is in the test set. You can extract the corresponding deep features, compute their differences exactly like you did in this example, and then use this model to predict whether these are from the same person or different person. And as a result, prepare a CSV file that contains the probability for representing the same person. It is better to use probabilities than binary outputs like zeros and ones. With CSVM and the SVM model is able to produce probabilities as well, and that's probably much more accurate than would be using binary output zeros and ones. But with this, I thank you and wish you good luck for the competition, which is ending rather soon. Thank you.